This is a construction activity on page 448. I'm trying to keep this as undistorted as I can, but just because the angle that I'm making the video at, it may not look exactly like a rectangle. Okay, I'm going to do this a little bit differently than the book does, but that'll be so that you can explain 2 and 3 a little bit better. I'm going to draw a couple of parallel lines so that you can see why some of these angles have to be congruent. Okay, so I'm drawing the parallel lines that make up the sides of the rectangle. I'd almost made this video and then my camera quit on me, so I had to start over. Okay, so here we have a rectangle, and we know that a rectangle has 4 right angles, so we know that these lines are parallel because these are all right angles. If two lines are perpendicular to the same line, they're parallel to each other. So these are parallel and these are parallel. Okay, and that's going to be important because you're getting ready to draw a transversal. So the book tells you to draw a diagonal across your rectangle. Okay, so draw a diagonal across there. They kind of show you how to do that. All right, now we have a transversal that's going across 2 sets of parallel lines. So what I'm going to do is label the alternate interior angles. With these 2 parallel lines and this transversal, the alternate interior angles are right here. I'm going to label them both A because they're equal to each other. All right, then we have another set of parallel lines going across here and a transversal. So this is a set of alternate interior angles, and they're equal to each other, so I'm going to label those B. So here I have 2 triangles that I know right now are going to be congruent to each other, but they're also going to be similar by angle-angle similarity. I'm going to move that so that it's not creating a bad background for us anymore. Okay, so I have 2 similar triangles. We know they're similar by angle-angle similarity. Okay, and angle A plus angle B. And what kind of angle does this have to be here? That's got to be a right angle. And a right angle is equaling 180 degrees to make our triangle. Okay, so we have angle A plus angle B plus a right angle, angle A plus angle B plus a right angle, and I've got these labeled the same because they're equal. Alright, now it says, well, it doesn't say this, but I'm going to say, go ahead and cut your 2 triangles apart. They're telling you to fold it so that you can make an altitude. Now, we're not going to do that. We're going to make it a different way. I want to illustrate for you these angles so that you can explain better. Okay, so we're going to take one of the triangles, and instead of folding it, if you take your protractor, this is 4 right angles. So if you line this one up along the base of your triangle, and put the edge of your protractor right up there to the point, you can draw an altitude. It does say draw, not construct, so perfection is not required. Okay, now I want to point out to you that with the first 2 triangles that we had, we said angle A plus, well, the A's were congruent. We can see they're congruent because we can put them on top of each other and they match up exactly. The B's are congruent, we know that. Angle A plus angle B plus a right angle is the triangle. Okay, so angle A plus angle B plus a right angle. I'm going to draw that here now. Okay, now I'm going to cut these 2 triangles apart. Alright, so I have 2 right angles right here. I constructed them as right angles on purpose. Okay, so if angle A and a right angle are in this triangle to equal 180 degrees, what does the last angle have to be? It has to be equal to angle B, because angle A plus angle B, since those are congruent, plus a right angle is equal to 180 degrees. Okay, so this one has a right angle and angle B, so the last angle must be angle A. Now we can actually verify this by laying the triangles on top of each other. Let's put the right angles down here in the left-hand side, and the medium triangle is almost as big as the big triangle. And then the baby triangle because I had a real long, skinny rectangle. Okay, so there are three similar triangles. Okay, now this is the hypotenuse. I'm going to write that with a little h. Now, when you move these things around to make them line up, things are going to turn upside down. Okay, now remember that the small angle was angle A, so I'm going to label the back of these triangles with angle A, and the larger angle was angle B, and then of course the right angle is a right angle. I'm going to do the same thing here. Okay, so I've labeled the hypotenuse as a cursive H, little h. Now I'm going to label all of the sides that are proportional with the small letter in cursive that's across from it. So this is A, so this is side A, and this one is side A, and this one is side A. And then I'm going to go across from B, and I'm going to label that with a small b. So all of our small b's should match up, and all of our small h's should match up. All right, I kind of have to do that on both sides, because if you don't, you won't be able to flip them around. So I'm going to label the other side as well. H, little a is across from big A, and little b is across from big B. Well, nothing's marked on this one. This is angle B, this is little angle A, this is the hypotenuse, and little a is across from big A and little b. Okay, so it says explain how you would show that the green triangle, that's the large triangle, is similar to the red triangle, that's the little triangle. Okay, and we know that when we cut it apart, put it back together, okay, so we're looking at these two triangles. Okay, so the way that we know is that when we cut our transversal, we had two alternate interior angles that were congruent and two right angles that were congruent. When we cut our diagonal, I called it a transversal. Okay, so we know that they're similar because we had angle-angle similarity. Then the next question was, how do you know that the blue triangle and the red triangle are similar? Well, when we cut this one, we have from the first triangle, this is why we started with that, from the first triangle we had our angle A's that were congruent and angle B, and so when we made two right angles here, we split it into these two were complementary with this right angle, and now when we cut this, these two have to be complementary to this right angle in the same way that these two are complementary to this right angle. Alright, it says the geometric mean of A and B is x. Now remember the x is the same, so you've got A is to B as, A is to x as x is to B. Alright, so it says write a proportion involving the side lengths of two of your triangles so that one side length is the geometric mean of the other. Now, look at how the different ways are that they can match up. See how this matches up. This length is the same, and it's related to both of these triangles. Notice that side B is to side A as side B is to side A. And notice that A and B are the same. So we've got this A and B thing going on. Let's just look at it and say, where can we put an X that's the same right here? Well, here we have the long side. Okay, now the hypotenuse is never called the long side of a right triangle. So we have the long leg of the medium triangle is to the short leg of the medium triangle. See, because when you look at the medium triangle, we've got a long leg, we've got a short leg, and we've got a hypotenuse. Okay, so the long leg of the medium triangle is to x, as x is to the short side. So we've got long side is to short side, as long side is to short side. But the long and the short side are actually exactly the same, and that's how it becomes a geometric mean. So it says, write a proportion involving the side lengths of two of your triangles so that one side length is the geometric mean of the other. So in this one, we have B is to X as X is to A. I don't really know how we can, I guess we'll have to give them letters, different letters. I guess what you could do is you could say, you know what, I'm going to leave that up to your thinking about that. You could put letters on the sides. You could name the lengths if you wanted to. Now you can also relate it to the big triangle. You could say, since the big triangle, that's the long side of the big triangle, the long leg, and you could say the long leg is to the long leg as the long side is to the long side. I don't know if that made sense. Okay, so, but you only need to get one of those proportions, and you can kind of look at those and figure some other ways that you might want to name them.